Hey guys, how's it going? All right, so the goal for the day is to talk about the difference between equations and inequalities. We have taught this to you separately, but now I want you to kind of see them side by side because I knew a lot of students were struggling with it. So we now have a new lesson kind of comparing the two and making sure everybody knows the differences. This video might be a little long, but trust me, there's a lot of good things in it. All right, so for starters, an equation is something that you simply need to solve for a variable or a letter. Like, for example, we're going to see one in a minute, but an equation like just solve for x. Like, what is x? Like, x equals 5. You get to your final answer. So that's what an equation is. An inequality, that's when the equal sign now becomes one of these signs. A less than sign, greater than sign, less than or equal to, or greater than or equal to. If it helps you remember, whatever way that it's opening up, that one would be bigger. So if it was like 2 would be smaller than 5. Alligator always opens up to the bigger amount. Um, so the next part is an inequality has these signs. So it's no longer equal, but it could also be other things. It could be only less than, greater than. It changes up some things, but how you solve them is very, very similar. Also, when you're dealing with inequalities, you're still solving for the letter like you normally would in an equation, but they have special rules to remember. So if, for example, you ever multiplied or divided both sides of an equation by a negative number, we need to remember that that sign flipped. Um, and when we also graph, there's a lot of neat little tricks to remember. But for example, the less than and greater than sign, they are not underlined. Therefore, if you graphed it, it would be a dotted line on an XY graph, or if it would just be an open circle at that point, and you'll see that in a minute. If you see a solid line underneath, when you graph it, it is a solid line. That's how I remember it. Also, it would be a solid circle if you saw a simple graph of it. So knowing those, let's go ahead and dive into some problems. I have 10 of them, but we're going to solve them in all three ways. So it's almost like doing 30 problems, but they won't take that long. We're starting with some real easy ones, and then we're going to graduate to the ugly ones. So, for example, your equal sign. Let's start off with this one. Nice if my pen worked. There it goes. All right. So x plus 5 is equal to 10. And we're going to solve an inequality very similar to it. X plus 5 is less than 10. Okay. And at the end, we'll graph the inequality. So the equal sign, x plus 5 equals 10. Well, what do we do there? To get x by itself, all you need to do is subtract 5 from both sides. And we get an answer of x equals 5. And you're done. That's the equation. Now, in an inequality, nothing is going to change. You are going to subtract 5 from both sides, and x is less than, that's the less than symbol as we mentioned above, 5. X is less than 5. And if you had to graph x is less than 5, there's two ways to actually see that. If it was a simple graph, like just on the x-axis, then we know something happens at the number 5, correct? 0, 1, 2, 3, 4, 5. And remember the rules up here. It's either a dotted line, but we don't have that. It's an open circle. So at 5, I need to make an open circle at 5. And what does less than mean? Do I go left? I don't know what that looks like for you guys, but do I go left or do I go right? So if it's less than, you need to go towards the smaller numbers. So we shaded to the left. Okay. Also on a XY chart, that brings up the other piece. So if it just said x is less than 5, then the x-axis at 5, which would be 1, 2, 3, 4, 5, you would have a dotted line. And again, what numbers are less than 5? Well, everything to the left, so it would be this entire piece shaded. So notice it's almost the exact same thing as this. It's just in 2 dimensions. Okay, let's try again with number 2. 2x minus 1 is equal to negative 9. And then we're going to do 2x minus 1 is greater than or equal to negative 9. All right, so very first step, we want to get x by itself. So let's try to see what to do here. Just like we did in the last problem, get rid of everything that's not around x for right now. Like we can get rid of minus 1 really easy by adding 1 to both sides. So now we have 2x is equal to, well, negative 9 plus 1 is negative 8. The final step is to divide both sides, because this is 2 times x. To get rid of multiplication, we use division. And x will equal negative 4. Okay, same process here. We change that equal sign and we just change it to like a greater than or equal to sign. Then we would have to, again, add 1 to both sides. 2x is greater than or equal to negative 8. Nothing has changed yet. And now we need to divide both sides by 2. Now we need to be careful of that rule. If you ever multiply or divide, that was here. If you ever multiply or divide both sides by a negative number, the sign flips. Well, we just divided both sides by a positive number, so the sign does not flip. So x will still be greater than or equal to negative 4. And on our graph, if we had to graph that, remember if it was a simple graph, like so, something would be happening at negative 4. It's underlined, meaning it's a solid dot there. And greater than, what numbers are greater than negative 4? That would be everything going to the right. If it were 2-dimensional, again, x-axis at negative 4, because it's a solid line underneath, we would have a solid line, and everything to the right would be shaded. Okay, moving on to our third example. Okay, negative 3x is equal to 21, and we're going to compare that to negative 3x is greater than 21. This one we really need to pay attention to. All right, so when I solve this problem, this is negative 3 times x. I can get rid of that multiplication by using division. And when you divide, you always divide by the exact same number you're trying to get rid of. You divide by that negative 3. Okay, x equals, well, positive over negative is negative. 21 divided by 3 is 7. And there's our answer. When we deal with inequalities, again, same steps. We need to get rid of multiplication by using division. So I'm going to divide by negative 3 on both sides. And here is where it comes into play. We just divided both sides of the equation by a negative number. So our sign must flip. And that's exactly what we did. We divided by a negative number on both sides, so our sign must flip. This is what most of us miss when we solve these. Everybody misses flipping the sign, so we got to remember that rule. So it goes from greater than to less than, and this is still negative 7. So notice the difference. There's a sign change as compared to your normal solving. All right, so now when we graph this, again, regular number line, something happens at, looks like, oops, here's 0 and here's negative 7. So we have a open circle at negative 7, and it's shaded, it's less than, so numbers smaller than that would go this way. On an XY chart, we would have x is less than negative 7, So x at -7, we would have a solid or dotted line. Well, it's not underlined, so it's going to be a dotted line on our graph, and it's still shaded to the left. Okay. Next one. Number 4. We have 5 minus 2x is equal to 1. And 5 minus 2x, we're going to compare it to less than or equal to 1. So here we go. A little bit tricky on this one, but how do we get rid of the plus 5? That's all by itself. We get rid of that by subtracting 5 from both sides. So I now have negative 2x is equal to, that would be 1 minus 5 is negative 4. Dividing both sides by negative 2, that would now give us x equals, negative over negative is positive, and that would give us 4 divided by 2 is 2. Okay. For the inequality, same steps, right? We would subtract 5 from both sides. That doesn't do anything. So I still have negative 2x less than or equal to negative 4. Now to get rid of this, we divided by negative 2, right? So I'm going to divide by negative 2. And again, what happens when we multiply or divide both sides by a negative number? Well, we know now that the sign has to flip. And that would, again, change the problem just a little bit. Okay, so graphing. Something happens at 2. So I'm just going to make a 2 on there. It's greater than or equal to, meaning it's a solid dot. And greater than, meaning shading it to the right, bigger numbers. On the XY chart, same thing. It will be x at 2, correct? So here's 2 on the x-axis. It's a solid line, so we're going to make a solid line. And it's greater than, meaning we need to shade to the right. Okay. Next one, that was what? That was number 4. I don't want to lose track of my numbers. All right, so the next one, let's go ahead and jump into number 5. We're kind of increasing the difficulty now. Number 5, we got negative 4 going into 3x plus 1 equals 8. Comparing it to negative 4 parentheses, 3x plus 1 is less than 8. All right. So whenever you see a number and a parenthesis, that implies that we need to distribute. So when we distribute, remember that's multiplication. So negative 4 times 3x is negative 12x. And remember, this is also multiplication. Negative 4 times positive 1 is negative 4. So our next step, now this looks like our previous problem up here. You get rid of the little numbers away from x first, like minus 4, by adding 4. And negative 12x is equal to 12. My final step to get rid of negative 12 is I need to divide it by negative 12. And my final answer is x equals negative 1. Okay, let's compare that to the inequality. Again, same steps, everything's the same, but you got to keep track of that sign and which way it goes. So when we distribute, same steps, that's going to be negative 12x. That'll be negative 4, still less than 8, because we only multiplied one side by a negative number, not both. So sign stays the same. Next, get rid of the minus 4 by adding 4, just like we did on the other. Negative 12x is still less than 12. The last step, what do? Well, we divide by a negative 12. And when we do that, we are dividing both sides by a negative. Therefore, sign must flip. Okay, so x is greater than -1. Again, on the graph, something happens at -1. It's not underlined, meaning it's going to be an open circle. And it's greater than, meaning we're shading to the right. Next, on an XY chart, that would look like x at -1, and it would be a dotted line because it's not underlined, and it would be going to the right because it's greater than. Okay. Now we're going to graduate to problems that really more like graphs, so you can see what the differences are there. So we're going to start off with y equals 2x plus 1. I know I'm off the page. Give me just a second. Okay, so y equals 2x plus 1 versus y is greater than or equal to 2x plus 1. So let's remember our graphs on this one. So there's nothing to solve here. These are already in y equals mx plus b form. They're not telling you to solve for x or y. They're already solved for y. So all you have to do is understand the difference in the graph. So equal sign, let's refresh our memory on some things. I already know this is mx plus b. M is my slope, b is my y-intercept. That's where I always start. It crosses the y-axis at 1. So there it is. My second point, my slope is 2. If y'all remember, 2 can be written as a fraction. It can be written as 2 over 1. And so rise over run, that's our slope, correct? So from our point, we need to rise 2 and run 1. So rise 2 and run 1. That's up 2 and over 1. Okay, and there is my line. Now, it says y is equal to. That means it is a solid line, if I can graph one. And that is it. Now, when you see inequalities, that's where we did that whole, what side do we shade? Was it left? Was it right? Up, down? We didn't know. So let's attempt that one. It's not going to be any different except for the very end. So again, my first point is at 1. My slope is 2 over 1, so I'm still going to go up 2 over 1. Notice the points are exactly the same. But now I need to pay attention to my sign. Is there a solid line underneath? Yes. Therefore, it is a solid line. Right? Because that means equal to, just like this one was. But it's also greater than or equal to. So greater than means everything bigger or everything up. Less than would be everything smaller, everything down. So because it's a greater than symbol, I need to shade upwards. So if I put my hand on the line, I'm going to shade up on my paper. So that would be this way. That is the difference. Okay, so let's try another one. We only have 10 of these, remember, so we're getting there. And I tried to make sure I'd put enough examples to where you would understand every one of them. So y equals -1/3 x minus 2. And we're going to compare that to y equals, I lied, don't look at that. Y is, I have a little cheat sheet. Wrote some problems down to help me remember all these. -1/3 x minus 2. So same problem, except instead of an equal sign, this one has a less than sign. All right, so here we go. The very first step to graph this is I have to start at -2 on my y-axis. So -1, -2. There it is. I know this is my slope. It's -1/3. It might help you if you just write the slope as -1 over 3, which is your rise over run. So my rise, meaning up, is a negative number, which means I need to go down. So I'm going to be going down 1, and I'm going to be going to the right 3. This one is always to the right. So down 1 to the right 3. So my point, down 1 over 1, 2, 3. There's my second point. Again, it's an equal sign, which means that is it. There's my graph. Now, as we just talked about, is this one going to be any different? No, not until we get to the actual graphing part. Our points are going to be in the same spot. For example, -2, there it is. Our slope, down 1 to the right 3. Points are in the same spot, but here's where you got to think. This says less than, not equal to. So our line, is it a solid line or is it a dotted line? Well, now it's going to be dotted. This is a dotted line as compared to our last problem. Our last problem, it was underlined, therefore solid. This one is not underlined, therefore it is dotted. And it says y is less than this. Less than means it's going to be smaller, or we're going to be shading downwards. So if I put my hand on my graph, I'm going to shade down on the paper. And that is all. Okay. Next. Getting to our little more increasingly difficult problems. So number 8 of 10 says 2x plus y is equal to -5. And we're going to compare that to 2x plus y is less than or equal to -5. So you're going to notice we can't graph these because they're not in y equals mx plus b form, but we can put them in that form. So I can take this 2x and move it to the other side. How do you get rid of positive 2x? Well, I subtract 2x from both sides. And remember, these are two separate things. You cannot combine them together, but you can write them in this order, such as y equals mx, that would be -2x, plus b would be -5. Let's go ahead and do the same thing on this one, and then we'll graph. Again, I'm going to subtract 2x from both sides. So now I have y is still less than or equal to -2x minus 5. Okay, so now I just want to graph these. Well, if I look at my graph, I already know this crosses the y-axis at -5. So that's -1, 2, 3, 4, 5. And there it is. Okay, I also know my slope is -2. I need to make it a fraction over 1. So that's my rise over run. Well, if I'm rising a negative number, meaning I'm going down 2, and run is always to the right. So down 2, right 1. So down 2, right 1. Okay, it's an equal sign. I just graph my line, and we're good. Problem solved. If I wanted to graph this one, again, we just talked about this. The points are not going to change. The points are in exactly the same spot. So I have a point at -5. Using my slope, I'd be going down 2 and over 1, just like we did. So down 2 over 1. Now, this one says less than or equal to. Because of the equal to, if you see a solid line, it is a solid line. There we go. And it says it's less than. Less than means smaller or down. So if I put my hand on my graph, I need to shade down the paper. So there it is. Okay. Second to last problem. Get excited. All right, so the next one, number 9, we have 2x minus y is equal to 3. We're going to compare it to 2x minus y is greater than 3. So, first step, just like we did last time, we can get rid of 2x by subtracting 2x from both sides. Let's go ahead and solve them both at the same time. Let's just subtract 2x. So I'm left with negative y equals mx plus b, negative 2x plus 3. Same here, negative y is greater than negative 2x plus 3. So now, the final step, this gets a lot of people. What's in front of the y right now? Well, there's a negative 1 right in there. So to get rid of that, we have to divide both sides by negative 1. Same on this problem. Hopefully this is something standing out to you. So this goes away, and I have y is equal to a negative over a negative is positive. 2 over 1 is 2. There's an x with it. 3 divided by negative 1 is negative 3. Finished. This problem, negative over negative, we're good. We get y. Same thing here. Negative over negative is positive. That would be 2x. And 3 divided by negative 1 is negative 3. Same thing as last problem. But we just divided both sides of the equation by a negative number. That comes back to haunt you forever. So the sign must flip. Okay, so that is what usually gets majority of my students. So graphing it really quickly. Starts at negative 3. 1, 2, 3. There's my point. My slope is 2 over 1, so rise 2, run 1, rise 2, run 1, and it's an equal sign, and we're done. Same thing on this graph. Same points. I go down 3, I go up 2 and over 1. We have to pause and look at our problem. It is not underlined, so therefore it's not a solid line, which means it is dotted. And it says it's less than, meaning we need to shade down our paper. So hands on the graph, shading downwards. Okay. The last one, save the best for last, so we can call it quits for the day. I have a negative 2x minus 2y equals 8. And a negative 2x minus 2y is greater than or equal to 8. So next step, to get rid of, we won't get y by itself, so let's get rid of the other stuff. You get rid of minus 2x by adding 2x to both sides. I'm going to solve them both at the same time because we should be good at that now, realizing that they're exactly the same process. Negative 2y is now equal to mx plus b, so 2x plus 8. Same thing here, negative 2y, still greater than or equal to 2x plus 8. Okay, the next step that does divide the differences between equal signs and inequalities. I now have to get rid of negative 2 times y by dividing both sides by negative 2. When we do that, we get an answer of y equals 2 divided by negative 2 is negative 1x. We can even put a 1 there if that helps you. 8 divided by negative 2 is negative 4. This one, same thing, but we just divided both sides by a negative number, meaning our sign better flip, getting our same answer as we did over here. So when we graph it, First point is at -4. 1, 2, 3, 4. I'm going to go, it's a -1 as a fraction would be -1/1. So remember, that's rise over run. So I'm rising -1, meaning down 1, right 1. I need to go down 1, right 1. And there's my line. Had to make it tiny. This graph, again, same 2 points, right? So we're going to go down 4. Then I go down 1 to the right 1. It's a solid line because it's underlined. And it says it's less than or equal to. Less than meaning put my hand down on the paper and go down because it's less than. Smaller numbers. Alrighty guys, sorry for the long video, but we really needed to make sure we knew the differences between those. I hope this helps, and I'll catch you later.